Hello everyone. Hey, I'm still trying to figure out some details with the YouTube live stream setup, so apologies for the delay. And yeah, please let me know if you can hear me and everything is working as expected. Hello everyone. Hey. Yeah, if the stream works as intended, please leave a message in chat. And yeah, I'm just gonna need maybe a couple minutes to fix a couple of issues in the stream setup, and then we can start. Oh yes, for the people that just joined, just waiting for a little bit for people to join before we start, and also trying to figure out some issues with the streaming setup, because I haven't streamed in 3 years now, so a lot has changed. But yeah, please type something in chat if you're here, and let us know if there's any issues with the audio or video or something. And then we'll get started soon. Let's check if this thing is working. It looks good. This is not so good. Let's see. So yeah, again, just as a reminder for people that just joined, we're gonna build a small web app today. We're also gonna play with a lot of data, but it's not 100% clear what we'll build, so we can just figure it out as we go. You can leave some feedback in the chat, and we'll decide. Yeah, so I think since we have most people already here, maybe I'll just switch to presenting my whole screen. It's going to be easier, and we can get started. Let me just try one more thing. Put some music in the background, maybe. But is the audio quality fine, by the way, on the mic? That's one thing that I'm not sure about. Actually, let me just stop the music. It's going to be very distracting. Okay, so we can get started, guys. Welcome back. It's been a while since one of these streams. So today I was thinking we can probably play around with some data related to video games. Originally I was thinking of something related to movies, but I think there's already a billion videos about that on YouTube. So I can show you what the data looks like. Maybe we can start with that. Okay, so let me just open my folder. And so yeah, and the second part of that will be building a web app. We'll see how much work we can get done today. So yeah, let's switch to this. So I just went on actually, went on Kaggle. So Kaggle, for people that don't know it, it's a website with a whole bunch of datasets that are free for use. Sorry, one second. And yeah, I went, type Steam and dataset, and as you can see, there's quite a lot of datasets related to Steam. Steam, if you don't know it, or for the small number of people that maybe don't know Steam, it's the biggest online store to purchase games on PC. And so out of these datasets, there's a bunch of things that seem interesting. So, you know, this is just an example. This is not necessarily the one we're going to use. But you have almost every single game on Steam when it was released, and a bunch of information, including what type of game this is, etc. And in some of the datasets you also have people that bought different types of products and reviews from people. So yeah, I think this might be a good place to start. You can just take one of these datasets and play around with it a little bit. And just to show kind of the end result. So the end result will be a web app built with this framework called NextJS. So this is, these days, this is like the most popular way to build a web app, I guess. And it also uses this framework called React. So we're going to try to combine these two. So train some machine learning model or do some data analysis, and at the same time build a web app that uses this data, which is pretty ambitious. Plus, I'm having issues with my streaming setup, so I'm not sure we're going to be able to do everything, but yeah, we can start somewhere. So I'm actually not sure if we should start with the data side or the web side. So maybe this is something where I can get some feedback from the people that are already watching. What would you prefer to start? Are you more interested in the web development part, so building a simple web server and front end, or more interested in just looking at the data, starting to play around with it, and build a mini recommender system or a search or something like that? What is more interesting for you guys? Oh, apparently there's some echo. Okay, give me 1 second. Let me try to figure out what's going on. Yeah, so while I'm figuring out all the stream issues as usual, just let me know if you would be more interested in web dev or more like machine learning and data analysis. And we'll try to figure that out. Let me just put this here. So is it better now? I think it should be better now. I removed one source of echo, so please let me know if the quality of the audio has improved. But yeah, okay. There's only one person that gave their vote so far, going for more the ML side. So I would be also up for starting with that. I think once we have a better idea about the data we have and how it can be used, it's going to be easier to decide what the web app should look like. So let's maybe start there. So let's do that. So let me go back to my terminal. So I already kind of started something, a small setup here. So we have, let me actually remove this, that way we can start from pretty much from scratch. So we're going to use something called Jupyter. Jupyter is basically tool/library that allows you to write Python in an interactive way. And it's something that I use pretty much on a daily basis. It's my favorite way to experiment with data and try new ideas and such. So in Jupyter, once it starts, you get a web UI inside your browser, and you can just create a new notebook. So let's call this, what do we call this? Let's call it, the project, let's call the project Game Oracle. So let's call this Game Oracle. And you can write anything. So you can write, like, I don't know, arbitrary Python code, and it gives you some output. So now what's more interesting is all the data analysis stack in Python. And let me maybe zoom in. I think it's way too small right now. Okay, so Pandas is a library that allows you to read data and analyze it. And for example, we can read a CSV file with Pandas. CSV is a common format, when you use Excel or something like that. The data will be in the CSV format. So if you go into the data directory, you'll notice I already have a bunch of stuff here. And I think this directory in particular, which is called Steam Data, has a bunch of stuff in it. It was data with media, is what it was called, sorry. So we can take a look at some of these, and yeah, I don't know if, well, maybe this is not the best way to look at the data. Let me open it instead in here. So in this data set, we have a bunch of games from Steam. So, you know, Counter-Strike, Team Fortress. For every game, we have how many positive ratings it got, negative ratings, price. But more interestingly, we have a lot of media related to this. So I guess the files are pretty big, so VS Code doesn't want to use them. Oh. Yeah, so we have a bunch of data like a description of the place, a description of the game, a title, and there's also here a bunch of screenshots, videos. So I think this would make something interesting for a web app, because we can not only show the name of the game, but also show images from it. So as an example, we can take this image, and you can see this is an image from the game Counter-Strike. So yeah, I think this is maybe a good start. So let's open this one. Let's call it df as data frame. Yeah, and in chat, please let me know if the text is not clear or something like that. Okay, so as we said, in this data set, we have a bunch of games. How many games do we have? We have 27,000 games, so that's quite a lot of games. And we saw earlier that we have this Steam media one. So again, same thing, you do PD for pandas, read CSV, and you just give the path. Oh. It's here. And this one, let's call it media df. And so what does media df look like? Like sample allows us to take some examples. So we take 3 examples here. So, and we get a bunch of stuff, right? So we even have movies. We have videos from every game. Thing is, in this data frame, you'll notice we don't have a name for the game. We just have the ID. So what we can do is we can join this data frame with the one before. And again, data frame just means like a table like this, a bit like an Excel spreadsheet. So let's do it this way. We'll first load this data frame, then we'll join these. So we'll do df equal, now I cannot even remember, is it merge? I think it's merge. So it's something like this, join. Okay, I really cannot remember how you do this. On app ID. It's like left on app ID, right on, because they didn't use the same. So what we're doing here is we're saying, okay, this file, join it with this other file. Let's maybe assign this to a temporary variable. Let's join it on this one, and for the left one, you know, here it's called app ID. On the right one, this is called Steam app ID. And when this value is equal to this one, you know, they will make just one row. Let's see if this works. It's merge, I guess. Yeah, okay, this worked exactly as we wanted. So this is an easier way to look at it. So now we have a bunch of games. So as you notice, this value is always equal to this one. And for every game, we have the name, everything, and we have the images and videos. But there was one more file that was particularly interesting. It's this Steam description one. So let's do the same thing again. Let's do description df equal data. And so this one, I don't know what it looks like. So let's take a look at it here. And, you know, just to keep the code simple, let's call this one games df, and let's do all the merging separately. So, sorry if I'm losing some of you. There's some questions. Is it possible that we develop the recommender system in Colab and the web app in VS Code? So yeah, there's some questions here. So we can develop, Colab is another way to use this Jupyter notebook thing we've opened. The difference is that Colab is not on your computer, it's basically in the cloud and allows you to just run on your phone or like any type of computer. You could do this, everything I'm doing here, you could do it on Colab. It's just less convenient because you have to keep copying the files back and forth and stuff. So what you said is possible. The one thing that is not possible is having a server running in the Colab instance and this calling that server, because Colab doesn't allow you to have a network calls going back and forth. As far as I know, you cannot have networking because that's a big risk, right? That would mean you have code that has access to the internet and you can run a web server and, you know, charge Google for your web server or something. So that, as far as I know, is not possible. Now let's go back to this. So we were opening this description df, and again, it's called Steam App ID. So like we did before, we will join all these 3 data frames such that we have one big data frame. So we've merged with media df, we will again merge with description df, and same thing as before, app ID right on Steam app ID. Or actually at this point we can just do on Steam app ID because we already have it. Okay, so that was very fast. Oh, sorry, like this. So as you see now we have one big data frame which has quite a lot of stuff. We have a description, we have some background image, and we have this. And so because this is very hard to analyze, to make it a bit more visual for the people following, let's actually visualize this data in HTML. So let's do this. So we're gonna go over the first, like 3 random games. So one way to do this is you can, again, sample, and you do iter rows. This allows you to, basically when you do this iter rows, it gives like an index, and it gives you a row. And a row is a line basically in this table. So we don't need the index, so we just do this. So if I print the row, oh, sorry. If I print the row, you'll see that we have, okay, this is one game, then there's a second game, and then there's a third game, which makes sense because we sampled 3 games, right? But we don't want to just print, right? Like we want to see maybe just, oh, that's kind of weird. Oh yeah, I guess I need to do this. Maybe we just want to see the name of the game, so we print this. But one very cool feature, actually I wonder if this is, I think this is only in Colab, right? Okay, it's fine if it's only in Colab, but in Jupyter it takes, so in Colab you can do something like this. You can do write HTML inside your Colab, and it just renders it. But okay, with Jupyter it's a bit more work, so I think we have to do something like this. From ipython.display import display HTML. And what we're gonna do is we're gonna start creating some HTML code. And so here we're gonna do like this. So I will explain what I'm doing here in a second. So when you do F, this is called an F string in Python. So you write like a regular string, except what goes between quotes is going to be interpreted as code. So this is Python code, the rest is just a regular constant string. And to explain what I mean, I can show you what we're generating at every time. So we're generating h1 this, h1 this, h1 this. But the cool thing is if I print what's in the HTML variable, I have a bunch of HTML. And with Jupyter, I can do HTML, give my HTML code, and ta-da, these are represented as titles. And if I did something like give it some color, you would see that they also have the same color, right? So this allows you to quickly start visualizing things. Now with text, maybe it's not that obvious why this is interesting, but very quickly it will start getting interesting because we have images, right? So we have this background image, which actually I'm not sure what that means, but let's see, we can figure out what it means. So let's add image source row background. And this is HTML, so I need to do this. Let's see what happens if I do this. Ta-da! So now for every game, we also display this image. Well, this background image is not very interesting. Maybe let's take a header image, I guess. That would be the main image of the game. And let's do one thing here to not sample. Like if I set random state to a value, it will always sample the same 3 games. So let's use header image. And there you go. Isn't that cool? Now, so for every game, we also see its image, so we can get a better idea about what type of game this is. Cool. So now we have a bunch of games, like 30,000 games. For every game, we have some screenshot, images, title. That's cool. So what could we do with this data? Well, one cool, and that's where I guess the ML part gets here, is that we have descriptions about the games. Actually, let me take a step back. Let's say I have all these games and I want to find similar games. What would you do? Well, the easiest thing is every game has a genre here, right? So is it an RPG? Is it an action game? Is it indie? So you could say, okay, if this is, I like RPG games, show me RPGs. The problem is there's so many RPGs in the world. There's probably, out of this 30,000 games, I'm guessing you would have 5,000 or something like that are RPGs. So that's not a very good way to recommend games to someone. So what we could do instead is we could look at something like a game description, which tends to have quite a lot of data. So let's actually do that. So we're going to add, in addition to the name of the game, let me just make this title a little bit smaller. Let's add this thing. So we'll add the paragraph where we also display the detailed description of the game. Detailed description. Okay, so let's take a look. So let's say this game, The Dig, I never heard about it. So Deep Space, Steven Spielberg, NASA, spacecraft. So now I have a much better idea about what this game is about, right? Like 2 locations, Boston. So this is a game that happens in space. It involves some highly evolved civilizations, so some aliens. It involves a whole bunch of stuff. That's cool. This one, you can already see it says that it's an arcade space shooter, so that already tells you a lot about the game. It's skill-based, it involves bases, there's some procedurally generated content. So as you can see in the detailed description, we have quite a lot of information. So what could we do with this description? Well, it's not very easy to compare text, like one long text to another long text, right? So what we need to do is we need to pre-process it in some way. So there are we could use the very simple ways. That's usually what I do in these videos, right? We go to like the very, very basics and start to build from there. But today, since we're also trying to build some kind of web app afterwards, I will go straight to what I would use, I guess, in practice if I wanted to build something. And that is what we have in this other tab. So let me actually take a step back here and show you the page for this. Oh, interesting. It's not working. Hugging Face is, that's really like the peak of bad luck. Hugging Face is basically like the model hub that everyone uses to load models. And it's just my luck that while live streaming, Hugging Face is not online. Okay, I hope that at least my model can be loaded. Let's try. So let's try to load this model, and then I will try to explain what model this is. So yeah, luckily I downloaded the model yesterday, so hopefully it doesn't have to call a Hugging Face and it works fine. Let's see. Ah, awesome. Okay, so it's working. I got scared there for a second. So yeah, luckily I downloaded the model yesterday, but I guess otherwise we wouldn't be able to try it. Okay, so what is this model that I'm downloading here? So there's a lot to explain. We're not going to be able to go into it, though maybe I should make some video about this, but this is basically a transformer model, which is like a type of model that can process text in a, like, let's say, sophisticated way. And specifically, this model is optimized such that it processes a whole bunch of text, and as an output, it gives you an embedding, and an embedding is basically a bunch of numbers, as you can see here. And it gives you a bunch of numbers such that texts that talk about similar topics will be close to each other. So we can look at an example. Sorry, I think I had an example here, but let me maybe make an even simpler example. So let's say you have pizza is delicious, right? You have the capital of France is Paris, which, yeah. And you have, I don't know, I love burgers, right? So if we encode these sentences, we can encode them here. What went wrong here? I guess I'm not supposed to have an indent. Oh, okay. This is so slow. Okay, let's just move everything to the other column. So let's say I have these sentences, and basically we make an embedding out of them, and then we call this function. So this will compare every one of these vectors to the other one. So what we need to look at here is this. What this tells us is the distance between the first sentence, which is pizza is delicious, and all the other sentences. If we look at this, we find that this sentence is quite far. So the cosine distance is between 0 and 1. 0 is, this is exactly the same kind of angle. So of course the sentence is the most similar to itself. But 0.67 means it's a bit far, right? But I love burgers, while it's not about pizza, is still very close. Why? Because it's a positive sentence and it talks about food as well, right? If I said I love pizza, then now this is very similar. It's 0.12, right? So it's almost close to 0. If I said pizza tastes good, now it's even closer. It's 0.05. If I said pizza is delish, now it's 0.04. So as you see, the closest the meaning of this sentence is getting to this one, the lower the distance. And if I say pizza, instead of saying delicious, I say disgusting, you'll notice now this is way worse, because now, okay, it is about pizza, it is about taste, but it's saying it's disgusting, it's not delicious. And if I say pizza, the pizza business pays well, now again it's a bit further, because yes, it is about pizza, but it's about business. It's not about whether it tastes well or bad. It's about a different topic. So as you can see, this is embedding kind of allows you to compare sentences to each other. So how will we use this? Well, as we've seen, we have this huge text. We also have a shorter version of the description. Maybe we can look at that one as well. So that one is called short description. So yeah, this one is a bit more condensed. Maybe it's good, maybe it's bad. We can try both and see what happens. The good thing about the short one is they will include the most important thing for people to understand about this game, right? So it will not have all this fluff that maybe, but in this case, for example, this is not very informative, right? So maybe let's start with the longer description and then we can see. So what can we do? We can create basically vectors from every single description. So let's do this. Let's do description embedding equal, and I think this was called detailed description, and we're gonna apply. So first let's initialize this. Let's actually do this at the top, because we're gonna be using this a lot. And what we can do is angle.encode. Oh yeah, I guess we're applying the function. So actually this doesn't, let's do it this way instead. We're gonna do angle.encode. This will return a bunch of vectors. Let's do to numpy equal true. And we'll get an embedding back. And let's see if this works. Text input must be of type string. Interesting. So is the description a list? So I thought that this was always a string. Sorry, let me figure this out. I'm a bit confused. So the description seems to be a string. Okay, maybe there's just a problem with this. Let me do toList. Okay, this seems to be working now. And let's see what happens once it's done. I should also say what I did here is quite ambitious, because if anything fails, like for example, this is encoded. Okay, let's stop it because I feel a bit sketchy about this. Let's just encode first 2 values. Okay, let's do this. Okay, so this is already no bueno. Okay, now I wonder if this is gonna work. Let's create a smaller data frame. And let's try. So this is good practice when you want to try something in pandas. Maybe first do it on a small number of rows instead of doing it on everything at once. Here it doesn't matter. We can just do. Does this work? Oh, see, this doesn't work. So how will we do this? Guess does this work? Pandas is always super annoying. Ah, okay. Just that did it. Apparently. So if I do this, I have a list of vectors. Cool. Okay, that was easier than I thought. So let's do this thing then. Oh yeah, we had to remove values and we had to add a list. So this is gonna take a while. I suspect it's gonna take a very long time. Actually, now I remember there was one more thing I wanted to do. So one thing I noticed in the descriptions is there's this HTML code. There's stuff like this in the descriptions, and I don't think we want that. And there you go, it crashed. So yeah, I don't think we necessarily want to have those kind of HTML tags. I'm not sure how this embedding thing is trained, but to me it feels like it could cause some problems to keep this data. So I'm not sure which way to go. Okay, maybe to start we can keep it there. Yeah, maybe we can keep it there for now, but yeah. So let me just, this crashed because I think we were encoding too many things at once, and that was too much to handle. So let's just do description by description maybe. Let's see how fast that goes if we do it that way. So let's do, this is by the way very inefficient. Usually you don't want to, you want to do this stuff in batch. But let's do something like this. Actually, it is a bit surprising that it would crash. I mean, I remember earlier I did 10,000 and it was fine. But it was also shorter sentences. Yeah, so as you can see, 100 sentences works fine. But yeah, we need to do 30,000. That's way larger. And also these are quite long descriptions. Yeah, let's think about this. So how do we do it? I mean, I guess we can always do, what about the shorter descriptions? Was it short? Okay, these are way faster. So maybe let's start with short description. I think this is not good. You know, let's do one thing. We're gonna create our own description, basically. We're gonna create this thing, which is, let's call it game description or game text. Let's go game text. So for every row, we're gonna do game text equal name, and then we put the game name. Right. We put the genres, and then we put summary. Right. So here we put the short description. And let's for now let's just do one, and let's just look. That's what it looks like. Right. So let's do Counter-Strike, for example. What does the description of Counter-Strike look like? Counter-Strike, action, and then short summary. Let's look at, maybe we have other interesting fields we'd like to include. Oh yes, Team Spy tags looks interesting, though it's pretty much similar to the genres. Categories doesn't look very interesting. Maybe developer. Developer could be interesting, I think. You would have games that are similar because they have the same developer. Yeah, let's do that. So let's do game name, developer. And I saw there's some questions on the chat. Maybe we can get back to those in a little bit. But okay, summary. So what does this look like now? Okay, so now we know it's a game developed by Valve themselves. It's action game, summary. Okay, cool. So let's do it for all the games. And then let's call this variable text. And let's move this as a feature here. Let's actually add this as part of the join that we do. So we join all of them, then we create the game text, and then we show. Okay, cool. So now that we've done this, actually I keep scrolling past this one. Let me just show one game. So it's faster. Now that we've done this, let's try to embed all the descriptions. So encode to list. Let's do text this time, and let's hope it doesn't crash. So let me maybe first start with 1000. Yeah, my computer is not doing well, so I suspect this is gonna crash, or I hope this is gonna crash and not kill the stream. So this is not good. Okay. Turns out embedding 1000 values all at once is probably not a good idea. So this is why it's good to work as a software engineer. You just get a bunch of free time. You know, if you want to read your mail or something while the embeddings are being computed, you can just do this. Okay, this seems to be stuck, so I will have to restart. Let's redo this again. And by the way, now I do wonder if we shouldn't use a smaller embedding, because this is a pretty big one. But let's try to use this one first. I think we might need to do things a little bit differently, such that it doesn't crash as easily. Oh, what happened here? Okay. So how can we do this in an efficient way? Let's think a little bit. It's kind of interesting. Earlier I did encode quite a lot of values, but somehow... So it does look like doing it by, like, let's say 50 at a time works fine. So okay, let's do this. I'm gonna look for... I saw something like this before. Array split. Perfect. This is exactly what I'm looking for. Okay, so what we're gonna do is we're gonna go over our data by chunks of 50, or let me check 100. Yeah, 100 works fine as well. Actually, now I'm curious, why does it crash? Okay, let's do chunks of 100. And actually, also let's do one thing. Maybe we care only about the most popular games, because I think we have a bunch of games here that we don't really care about. So let's see if we have a way to identify where the, I guess owners might be the right one. So maybe we can sort, but how is it possible that Counter-Strike has, oh no, this is not Counter-Strike. Okay, so maybe let's look at only the top 1000 games. So how would we do that? So we can do, let's sort by the minimum number of owners. So to get the minimum number of owners, we take owners, and it seems to be a string where you have like this character, and then the first part would be the minimum, and we can even make it an integer. So if I do this, and I look at minimum owner, you can see it's a number like this. So if I do sort values, minimum owners, and I sample 3 values, oh sorry, no, sample doesn't make sense then. Ascending false to take like basically the largest values, and I look at the first 3 and I do like this. Let's see what happens. What are the top games? So Dota 2, Counter-Strike, and PUBG, which makes total sense. These are the most popular games on Steam. So I like this a lot actually. Let's do it this way. We're gonna sort our data frames such that the most popular games come first. Actually, we don't have to sort it this way. We can just later use this. And so here, after this part, what we can do is we're only going to take the first 1000 games. Let's call this top df. So top df is what we did earlier. So minimum owners, ascending equal false, and we take, let's say, top 1000. And so now we can do our work on this top 1000. So let's say we embed 1000 values. Now I'm a little bit scared. Didn't it crash last time when we did it on 1000? Yeah, so maybe we still need to do the batching thing. So import numpy as np. Let's call this embeddings. And we do for, I guess, I've lost the thing, okay. NP array split. So for chunk in np array split, what we want to split is this text to list. I guess we only want the top df. And we want to split it by chunks of 200. So chunk embeddings equal something like this. So instead of this, we're going to have the text, chunk text, which is this way. And this is going to be, so we do a list of this, and then we do embeddings plus, yeah, let's do it this way. I think this should work, but let's see. Let's run this thing. What happened? Text input must be of type string, blah, 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 blah. Okay. What is the type of chunk text? Ah, it's a numpy array. I guess I have to do list here. So this doesn't. Okay. Cool. So it looks. What is going on though? Did I put the whole data frame? I put 1000. Let's see what happened here. Array split. So what does this array split do exactly? This will split over 3. So, no, wait, that's actually what we wanted, but I'm curious about what happened here. Why is it still running? No, it did finish running. Okay, now I'm very curious what happened in embeddings. Okay, there are 1000 values as I would have expected. I'm just curious why it showed so many lines here. So what was, for example, chunk text like? 5. How is it 5? So it's split into 200 pieces instead of splitting. Yeah, that's not how I expected the function to work. And also not how it looks here. But I guess, yeah, this is a bit ambiguous. Yeah, 4 splits by 4. Yeah, okay. So it's not what I expected. So what we should do here instead is this. So let's try this. Now this time it should only split it 5 times. So but we're saying split it into chunks of the size, the total divided by 200. So it's gonna split into 5 because it's 1000 times divided by 200. And yeah, this ran faster this time. And you can see it's split into chunks of this. But anyway, the result is the same. We get embeddings out, which is cool. Because this approach works, we can actually handle maybe 4000 top games. And let's do this. Okay, and soon we're gonna get to the cool part. I know I went into some obscure code and debugging all of this, but very, very soon we're gonna get into the cool part. Let's see, let me look at the chat if there's some questions. So yeah, please interrupt or ask questions in the chat if there's anything you don't understand. So this is working, it's way slowly. Let's see. So when this is done, what we're gonna have 4000 games. And for every one of these games, we're going to have an embedding, which is a vector that represents what this game is about. And yeah, very soon after this, we will basically have a way to compare games to each other because, you know, if there's 2 games and they have a very similar vector, that might mean that these games are very similar semantically. So maybe they both talk about spaceships, maybe they're both, I don't know, shooters set in Russia, maybe one is a shooter, one is a strategy game, but they are both mention minerals or something. But there must be something similar between them if their embeddings are close to each other. But I found this very curious that it's so slow. It ran super fast when we ran it on 1000. Why is it suddenly so slow with 4000? That is curious. I wonder if it's this last bit here, not the embedding computation that is slow. So I think I'm gonna restart. And this is like the 5th time we restart, but this is, you know, data scientist usual workflow. Okay. So I don't know, let me just do 400. And let's just do chunks of 100. I feel like almost, actually I can show you a cool feature. So there's this thing. I think you do it like this. Yeah, so it will compute how long something takes. So the cool thing is sometimes you don't know how you should do something. So here, I don't know if I should have bigger or smaller chunks. So as an example, I could have chunks of 50, and maybe this will be faster, right? Or in theory it should be slower, but I don't know. Well, here it looks like actually smaller chunks are better, unlike what I was thinking. I guess up to a certain extent. Okay, now it's basically the same. Okay, so given this takes 4 seconds, in theory it should take 40 seconds to do 4,000. But that's not exactly what happened when we did earlier. So let's just do the top 2,000 games for now. I think there's enough diversity in the top 2,000 that we should see some interesting things. And maybe next time, yeah, let me add this. So we can add this enumerate thing. It will, let's do this. So I'm just adding a little indicator to show us the progress as we're running the computation, because yeah, sometimes it looks like it's just stuck. So a very common thing you do here is you do something like this. This is saying basically only print every 5th one. So if the modulo 5, if you remember your maths, modulo 5 equals 0, this will only trigger for 0, 5, 10, etc. So if I do this, you see 0 out of 40. So this is just a cool way to see the progress as the computation is done. That way you don't worry, oh my god, my computer is dying or something. It's just slowly working through the data. Okay, so the cool thing now is we're going to have this, finally, we're going to have these 2,000 embeddings. And so what we can do, and there is a little bit of a risk of a crash here when I do this, but what we should be able to do is put our embeddings and get distance. Okay, actually that was ultra fast. So now we can compute distances. And if you notice here again, we have one game and there's many other games and there's very different distances. So you can see this second game is very similar, but this one is very dissimilar. So now we have a way to compare one game to the other. So how can we use this? Let me make it a little bit nicer. So first, maybe let me put this inside the data frame. I hope this will work as expected. Okay, this works fine. Put it here. And now what we can do is, let's say first we print the top games that we have. So let's say we do this. So that way we have an idea about the games. Okay, so Elder Scroll, Portal. So what I'm going to set up here is I'm going to set up a way to take one of these games and compare it to all the other games. So I think for this, actually, when it's one to many, I don't need this pairwise thing. I can just do cosine distance. What is it called? Okay, let's look at the documentation. Scikit-learn is a very commonly used library to compare, sorry, not to compare, it's used usually to train machine learning models. These days, not so much. People have switched to deep learning. But I like these functions that it has to compare vectors to each other. I mean, we can just keep them as is, I guess. So when we do this cosine distances, what we get is a huge matrix. So we can look at the shape. So we get 2,000 times 2,000. That's 4 million, I guess. So 4 million values where every vector is compared to every other vector. In this case, I only want to compare one vector to the others, which should be cheaper to do. So actually we can do it this way. So let's say we pick a game name. So as an example, let's say we pick Path of Exile, which I see in the list. I want to find this game. So I'm like, we're gonna do this. So this is how you look for stuff with pandas. You do this. So it's basically saying in this data frame, take the value whose name is this. So if we do this, what do we get out? We get out path of exile, the row for path of exile. Why? Because pandas looked at all the names and only this one has this thing. And here I'm gonna always assume there's one value, which is not always gonna be the case, but yeah. And so here, the cool thing is I have the embedding, right? So what I can do, and I guess let's call this embedding. What's embeddings? And let's remove the... because I'm a maniac and I need my columns to be called correctly. Okay, so we have an embedding. So I can take this embedding, actually, and I think I can just do dot product between this embedding and all the embeddings that I have. Oh yeah, it's just called embedding. So here I need to do like this. There's a transpose somewhere, but I can't remember now. I guess 2000 times. Oh yeah, this needs to be a matrix. Ah, it's very annoying. Okay, let's just do cosine distances, I guess. That's the other way to do it. So if I do cosine distances, I can pass two values. So first, I'm gonna give my embedding, so that's game row.embedding, and then I'm gonna give all the other embeddings. Even this is not working. Setting an array element with a sequence. All right. If there's one thing you learn from this session, it's that nothing works from the first time. You have to try. So so when you do this in Jupyter, it gives you the documentation. So, okay, so we need a thing of shape. This is a bunch of examples, and this is the dimension of the embedding. And same here. So in my mind, if I give, like, let's say I do this, in my mind this should have the right shape, but I have a feeling it does not. Yeah, so I have one thing, just one game, and its dimension is this. And if I look at shape, so this is where the problem is. So this, if I do this, okay. But this, yeah, so you need to, this shape thing is always super annoying. We just need to basically play a little bit with our data to make it fit correctly. So if I do this, I think now this works. Okay, cool. All right, this took quite a lot of work, but we basically now have this comparison that we wanted to do. So let's call it distances. And I will explain what just happened. So I feel like now suddenly it doesn't work great. Why doesn't it work now? Why doesn't it work now? What the fuck is going on? Yeah, sorry, because I had this line here. Okay, I'll explain what happened. So basically we have our game here, path of exile. Path of exile is a point in space. I don't know if there's a... Yeah, maybe this is a thing. Cool. So we have path of exile. It's like a point here. And we have... How do you change color in this thing? Okay. So anyway, you have a bunch of points. There's one game here, one game here, one game here. There's one here, and one here. So what we'd like is, me as a player, I played Path of Exile. I would like to find this game, and this one, right? These ones I don't care about. These ones, don't show them to me. I just want to find the closest points. So what we've done in the code here is we took the embedding for Path of Exile and we computed cosine distance, which is a very common way to compute distances between vectors. Yeah, that will give us an idea about how similar these are. And just very quickly, I can try to explain what cosine distance is. You can think of cosine distance as, let's say this is the space where these points are. And you know, you have a line. Okay, this was really bad. Do we have a... so let's say there's a line here that goes to all these points. So cosine distance is kind of the angle you have here. So all these are in the same area of the space. So these angles here, all these angles, they're about the same. They're very close. Whereas if you want to go, well, actually this game also would have a small cosine distance, although it's quite far away. So that is one problem with cosine. But this game all the way here, and this game all the way here, you can see their angles here are very different. So these would be considered very distant. But again, as you notice, this one has similar angle, yet it's very far away when you look at it in a Cartesian way, which is why there's also Cartesian distance. But anyway, this is just a first start. In theory, anyway, all these distances will never give us exactly what we want. Usually you would train a model to learn the correct distance you care about. But this is a good start. So what can we do with the distances we have? So one cool thing in pandas, there's this, in NumPy, you just call arcsort, and this will give you the index of the closest point. The index of the closest points to the one we compare to here, right? So what this means is 20 is the closest vector to this one. Then 90, 21. And we can check this by doing this, and we will see the distances in increasing values. So you have 0, then 0.26, then 0.275, etc. all the way to 0.59. So now we have basically the index. So let's call this sorted indices. Sorted indices. So what can we do with these sorted indices? Well, we can do something very, very cool with these sorted indices, which is that we can go through them. Can you guess what's the first index, by the way? We saw there was one with distance 0. The one with distance 0 is the game itself, right? Because we compare the point to itself, it's always going to be 0 distance. And by the way, sorry, let me take a quick look at the chat. I see there's a bunch of questions. And yeah, Adnan was asking about what we're building today, and yes, it's going to be a game recommender system. So, and so far, yeah, so we managed to compare every game to every other game, or in this case, just one game to the others. And now that we have these indices, so I can show you, we have a bunch of indices, but this is not very informative. What we can do is we can, let's call it similar game. We can go to our data frame and find which game that is. And now this is where the magic hopefully will appear. So we can show the name of this thing. Actually, we have this nice little thing we did here. Let's put it in a function. Let's call this display game. And given sorry. I don't know what's going on now. So we'll just put a little function that allows us to display games, because I think we're going to be displaying them everywhere. So here what we can do is just call it display game. Okay. The cool thing is now that we've put this inside a function, we can also call it here. So we do display game similar game. So what do we see? Of course, the first one is Path of Exile itself, which is cool. And you have a bunch of stuff. You have the photo. Then you have Conan Exiles. That's actually surprising. So Path of Exile is kind of an action RPG. Conan Exile is not really an action RPG. But I'm gonna guess that there's something about the setting of the two games that is similar. I guess that could make sense. Okay, this is a very long description. Okay, maybe, you know what? I'm gonna change this display thing to be short description instead, and genres. Okay, let's go back and display our similar games. So action adventure, blah blah blah. Okay, exile, cool. Stories, the path of destinies. This kind of makes sense. It's also action RPG. Throw of action, RPG, MMO. Behind the Mask of Prospect. I would say this is kind of similar, but here, okay, now we're hitting it. Grim Dawn actually is probably the most similar game to Path of Exile ever. And it would have been cool if Grim Dawn was a little bit higher in the list. Neverwinter, another excellent recommendation. Torchlight, again, Torchlight, very, very similar to Path of Exile. And this one I don't know, but it could possibly be similar. Now, this is, I would say this is promising, but also let's give it another go. Let's try another game. Counter-Strike, Global Offensive. So what games are most similar? Of course, Counter-Strike itself. Of course, Counter-Strike Original. Of course, Counter-Strike Source. Condition Zero. Some other Counter-Strike game that I never heard of. CS2D. As you notice, it didn't say Counter-Strike, it says CS, but yet we're able to find it. Team Fortress, very, very good. Team Fortress is a really well-known game, also released by Valve. Dota 2, not so much. Here, I feel like it's just the fact that it's developed by Valve that's played this. Easy Esports. I guess this is a client for Counter-Strike, so it came up. Team Fortress again. So yeah, very good. Like overall, the Half-Life is what Counter-Strike came from. So as you can see, these are very similar games. So this was very easy, right? Like we just took a bunch of text and we created an embedding for it, and then we compared these embeddings to each other. And we already have a pretty decent way to compare games. So I think, given we've already spent quite a lot of time on the data analysis part, we can try to start focus on try because it would take a lot of time to actually take what we built and make it into a web application. So maybe this is the right time to take a small break and just get some questions from chat. But yeah, please in chat, let me know what you think so far if you have any questions. Otherwise, I will just start moving now to building it into a web app. Let's see. Okay, so we'll start working on a web app then. So there's two things. One, we're going to use something called NextJS to build, I guess, the front end, and you can say back end also of the app. So here I'm not gonna explain what I'm doing here, but if you go to the Next.js website, they give you this command. You can run it and it will create basically a hello world kind of app that you can then edit to work on your thing. But I will do something else. So I'll also create what's called server, and this, or let's call it, instead of server, let's call it recommender, or server as well. So this server is gonna, let's go back to here. This server is gonna just do the recommender part. So we will have basically two apps. We will have one app that does all the smart machine learning stuff, and one that is only a dumb front end. It just does fancy, UI, and you click on it, it fetches data from the smart backend, etc. And the reason we do this is just because usually Next.js is JS based. So you cannot really call, easily call machine learning and similar things. Ooh, what did I do? I feel like oh yeah, okay. So for this, we're going to use yet another technology called FastAPI. But again, this part, I guess, is not necessary. It's just that we wrote our code in Python, and it's easier to call Python as well. But we could have easily done something else. We could have done all of this in NextJS if we're more comfortable with it. So for me, we're going to go to the website. We're going to take the simplest example of FastAPI and start from there. And I have no idea what this does, but let's call it get recommendations, I guess. I will explain all of this in a second. Just give me 1 second to set it up. And I think we're done. Oh, sorry. Let's see. So, okay, what is FastAPI? FastAPI allows you to build like an API, right, as the name says, which is basically an interface where you can call from the web. With FastAPI at least. So it's like you have a system, that system can do things, and people can call it. People can call it with certain methods and get certain data. I think once we start it, it'll be easier to explain. So as you can see, now if I go on this app, I get hello world. Why do I get hello world? Because here I in FastAPI, which is, as you can see, just like a handful of lines of code. We don't even need this line. We said that when someone goes on the root of the website, you return hello world. And I could have instead say, hello Hamida. And now if I refresh, I get hello Hamida, right? So what we want to do, I guess we don't care so much about the root. We want to have a system where I can get recommendations of video games. So let's have a backend called recommend. And what we're going to do is we're going to try to get the embeddings we computed earlier. So let me go back to this. I'm also going to do one thing. Now that we know that this actually works consistently, let's not be too greedy. So what I'm going to do is, now I'm just going to save this in CSV. Maybe we don't save it to CSV. Maybe we use another format. So I'm going to save the data that we already generated. So I think there's, I forget what it's called, Feather or something. No, not Feather, there's another one that is better. There's another format, Parquet. So the CSV is a very inefficient format. I don't recommend using CSV if you don't have to in most cases, unless you want the data to be loadable in a spreadsheet. So Parquet is much more efficient and also can allow us to save things like lists of numbers and such. But let's try and see first. I'm not 100% sure it will work. So let's call this game database, right? Okay, that was super fast. That worked. I'm really impressed. So what we can do now is we can have our little game DB. So we import pandas as usual, right? And we can add a little, the same way we did save Parquet, we can do read Parquet, such that, oh, interesting, it didn't save the game. Game database. Yeah, that does exist. It's interesting it didn't find it here. Ah, yes, of course, it's outside. Okay, so now this worked. So the cool thing is, let's say, now what we can do is if someone calls recommend with the game name, we can look for the game. So we do gamedb, and we could do equal, but let's do something a little bit more. Let's say you just need to find something that includes the name. So if I write Counter-Strike and I found Counter-Strike, though this doesn't actually work. Let's just do it this way. You need to give the exact name. Okay, let's just start with equal. And anyway, we need to implement also a search feature, which is something I forgot. Let's just do this. We look for the game. So then we have the game, and then we can just. I think there's a toDict thing, but I'm not sure. Let's try this. Let's see what happens. Okay, so we're on our thing. Sorry. And now that we run this, I got lost a little bit in my thoughts. Ah, yeah, okay. So now that we have this, we have, what was it called? Recommend. So this, we added a parameter here, right? Game name. So I'm gonna do this. Path of exile, right? I think it should know this. Oh, what happened? Cannot convert dictionary, blah, blah, blah. Okay. What if I return the name as this? I guess okay. Return PD series as JSON. Okay, there's a toJSON here that I wasn't aware of. Sorry, by the way, guys, I'm really switching from window to window. But okay, it worked. So as you can see, now we have a way where we can search for a game and we get all the data from the database. So we can call from anywhere on the web, and we get all this glorious data. So let's call this, actually, let's go back. Let's call this search. So this is just searching. So search. You give a game name and it gives you the closest thing. We can even go one step further. So there are like ways to find texts that are close to each other. So this is one of them. And again, I'm really sorry I'm jumping from one thing to the other. But with this library, which we can install like this, we can, there is an example somewhere. Yeah. So we can compute the distance between the query and all the names we have and pick the closest one, right? So I think Hamming distance, I forgot actually which one is most commonly used. Levenstein distance, I guess, is the one that is most commonly used. So let's go back here and then I'll explain what we're doing. So this function allows you to do this. So if I type path of exile, because I made a mistake, right? And what I really wanted is this one. So here the distance is 1, meaning I only need to add 1 character to fix it, right? If I did this, it would be 2, right? And if I did path of exile instead of exile, it would be 1 as well. Sorry, it would be 2. Yeah, it will be 1, I guess, because I will need to make one change, which is edit A to I, right? So if I had like Counter-Strike, then that would be a very large value. So the cool thing is if I go to my data frame and I go to name, and then for every name, I basically apply the difference between my query, let's say that's path of exile, and the name, right? So this will give me a bunch of values, and I can sort these values. And you see there's one here, which has only 3. There's only a distance of 3. So what is that value? If we look at what value that is. I'm a bit confused now. Did I make some mistake here? 172. Oh, sorry, no, I made a mistake. Oh, okay, path of exile. I lock and lock are two different things. Okay, so and if I did like counter strict like this, the lowest one is 0, and what is that? Counter strike, right? So now we can search games in a very fuzzy way. So we go back now. Let's look at this. So let's do basically the same logic. Sorry, let me just steal the logic I did here. So what we're gonna do is we're gonna compute distances. So we're gonna take a GameDB, take the name. Of course, we import this library. And this time, instead of being like hard-coded value, it's going to be whatever the user types. And so now we have distances, right? And let's say what we're going to do is we're going to return the top 3 matches and the distance. So we return, how do we do this? So let's do, let's say we return something like this. We return a bunch of values where I really wonder how to do this. I guess let's do this game. So we have a game, right? And that's this thing. And then we have a distance. And so this, we're gonna return something like this for index in distances.index. Okay. Well, this was, so I think this is how we do it. Let's go back to our thing. Let's see if this works now. Detail not font. What the fuck does that mean? Ah, yeah, now we have a search function, sorry. Oh, something crashed. Series has no attribute iteros. Iterate over value in the index series. So as usual, iter items. Okay, hopefully once this works, it will be a bit more clear where we're heading. Okay, I feel like I need to play around a little bit here to understand what's going on. So we have our distances. Let's call it dist. If I do a list of these, and I look at the first 3 values, this looks like what I want. Items. This looks like what I want. I wonder why it doesn't work when I do it. So I feel like this should be fine. Sort values, the items. Interesting. Something is going wrong, but I'm not exactly sure what it is. Let's see. No, it's not iterable. I think now I see what's going on. In that we cannot return this. I need to do the to JSON. I think that's what it was. Okay, cool. Nice. So as you can see, now let's type some other game. Let's say winter, I don't know. I'm not even sure what I'm looking for. So the anar apparently is pretty close to this. Panzer. Okay, I guess that's a very vague name, so let's type something more specific. Let's do Counter-Strike like we did earlier. Battle rights. That's kind of actually weird. Did I make another mistake again? What if I do Counter-Strike? Okay, Counter-Strike gives Counter-Strike. So I think it's just, yeah, this Levenstein distance, it's not perfect, right? So, okay, so now we have a way to search games. Now we need a way to recommend similar games. So let's say I do know what my game is. I have the ID for the game, and I want to find similar ones. So maybe let's go back. So one thing to do is maybe let's compute these embeddings for more values. Here, let me look at the top 5 only. Let's compute for 4,000 values. That's one thing to do. Maybe one more thing we can do is we can, trying to think out loud here. I guess we can, maybe for recommendation, we just pass the ID of the game. Though I would say, at this stage, given we're already at 2 hours, maybe we can start with search and then we move to recommendations. Let me just make sure that this finishes and that we can save it. And then we can start doing the more fun visual web app stuff with NextJS. Though I will probably have to figure out how to call FastAPI, like our server from NextJS, but that should be fine. Okay, so 4,000, that was very easy. Let's compare now. Let's say City Skyline. What are the most similar games to City Skyline? Cities in Motion, very good. This is, I think, from a very, very similar game. Cities XL as well. This is also excellent, very similar. So I'm very happy with the results. Here you can see that we get very similar games. If I look at The Witcher, what do I get? Open The Witcher. Witcher 3, Witcher 2, Witcher 1, which are of course the most similar. Thronebreaker, adventure game, Game of Thrones, makes sense. Child of Light is a bit surprising. This is also a bit surprising, but I guess there's like political things. So it kind of makes sense. Not bad at all. So okay, now that we have this, let me just clean up a little bit of this stuff. We save it. And yeah, let's now try to move to, I guess, more visual things. So what we're gonna do is we created this web app, right? So I'm gonna go back to my terminal. And now I'm gonna go to web app and we're gonna do this. And so we're gonna have two apps, or two servers, sorry, loaded at the same time. So remember this, we had the server that does the search, and then we have this one, which is a regular Next.js hello world kind of page. And yeah, so now we start with the more visual things. So enough with the machine learning. So if we go to web app, in Next.js, it's very simple. Let me just do this. So very first thing I do is I usually rename this to .ts. That way we have, or tsx, sorry. That way we use TypeScript. So TypeScript is like a typed version of JavaScript, basically. So first, I'm gonna get rid of all this stuff because we don't care about it. Let me just do like this. I think the last div maybe we have to keep. But all this stuff we can remove. We can remove this. Maybe we keep the footer thing. Can remove this. Let's call this game Oracle. And here we can remove. Let's put something here. Hello game Oracle. Right. That's cool. And then again, we're gonna remove all of this. And we're gonna remove all of this. Well, this probably we can keep. It doesn't matter too much. Now, though I'm thinking, let's sorry. Do you want to keep something here? No, actually, we can probably remove everything. Okay, so we've removed everything. We started from scratch. So what do we need? We need a search bar, right? So how do you do that in HTML? You put input type equal search. I think you have to close the input. Right, there you go. We have a search bar. Very cool. So what else do we need to do? I think there's one more thing I might need to do. So we need to set up, this is a weird thing I just learned, but you need to set up a custom app if you want to have any global CSS. It's like, this is really a detail, but we need to set this up, and let me maybe call this .js. And then I need to import my global styles. This is a very weird thing. I have no idea why this is not included in this. But yeah, just to show you what this does. What is going on? Oh yes, I guess. Weird. I'm not sure what's going on there. That is very interesting. Something just kind of broke. I guess maybe I don't need this. Okay. Yeah, now it works. Okay, so now to explain why I had to do all this stuff. Now if I go to say here, and I decide, you know what, I want the background of the page to be red, it will become red, right? So if I want to make it blue, I can make it blue. If I didn't make that change, then it doesn't work. So of course we keep it like this. Okay, so let's start doing a little bit of styling, I guess. We want some kind of header. I think there is now a div called thing called header like this. We want to have some kind of you know, game oracle, and so let's call this logo, and here let's say, does this work actually? I think it doesn't work. So here we have to do class name equals styles header. By the way, I'm learning NextJS with you. I've never used, I mean, I used it for 5 minutes before this thing, but I also have no idea what I'm doing. So let's say I set some background like this. Maybe slightly lighter color. And the logo is going to be this, and it's kind of weird. There's some margin or something around this H1. Yeah, I hate that thing. So H1 and all these by default they have a big margin. So margin 0. Okay. And then we add some padding here, so something like this. I always forget which one is the vertical. I guess this one is the vertical. Okay. Let's keep this one real size. I'm gonna remove this. So I'm just adding like a very minimal amount of style. And by the way, I like this website, which has some pretty nice color palette, so maybe we can steal some colors from here. So maybe it's the background at the top, and maybe I think white is fine though. Maybe this works. I don't know what you guys think. Meh, I don't like it too much. Or maybe something more colorful. I guess you guys get to decide if you have some very strong feeling about the colors. Okay, otherwise, yeah, well, maybe we just go with something like this. Actually, I like to just change sometimes the colors from here. So I can go to my logo and just, sorry. I feel like I'm spending way too much time on this. Okay, let's just do something like this. Let's just do a color that is kind of blending in the background. Cool. Okay, the search bar will definitely need a little bit of styling because it looks super ugly right now. I feel okay, yeah, search bar. So, why is this? Okay. So let's give it a lot of padding. What's going on here? It's weird that it didn't get styles.search bar. Oh, did I not save? Oh yeah, now it works. Okay, so let's just finish this so I can show you some cool things. You can make things more or less. Is it? Oh no, it's border radius. More or less rounded based on this parameter, right? So as you can see, the search box is a little bit more rounded now. So I don't like this. I think it's outline or border. So the default border that is given is pretty ugly usually. So we can just set something more subtle. Let's say. And let's make the search bar take pretty much the full height of the place. And let's make it a little bit higher. Okay. I guess to be honest, I should just probably set the font size. I guess that's what controls this, or okay, let's just go with this. This is absolutely ugly. Like this is one of the ugliest things I've ever built, probably. But this is a good start. We can move more to like the, I guess, more interesting code part. There was one more thing I wanted to do. Oh yeah, let me just put this class name. Yeah, let me just put this inside a div. And let's call it a container. And actually, I'm gonna close this. Let's put inside this container because then we can do something like this. So I always like to have a container because you can have some padding on the bunch side of the page. Okay, not both sides. Did I put the header inside? The header definitely I don't want to put inside. Why is this is what they called container. No. So in my case, I don't have that. Let's just keep the container thing, but let's call this content. Okay, so as you can see now, we can have like some padding like this. Let's actually put also some at the top. Okay, cool. So what we can do now, I think, is we can try to call our little backend every time someone types something. So because I don't know how to do that, NextJS on input change. We'll Google a little bit. So how does that work? On change, yeah, you just give a value. Okay. So we're gonna go to our input, make this here, and you just add onChange, and you add a function. So it can be like this. So E is an event in this case. And every time, what we're gonna do is we're gonna call our little API, and I forgot, oh yeah, and then you do then result something, which is data, then data. For now, we will just print whatever we got from, how about that? We just print it. Okay, so what will happen if I do this? It's gonna crash because there's no API. It's gonna be like, what is this? API search, I didn't find this. Well, the good news is we do have an API actually. It's just that it's in a different place. Now let me see if this is actually gonna work, because I think that, oh yeah, it's gonna be this course thing. Oh my god, it's gonna be very hard to fix, or hopefully not. So, okay, luckily I think that with FastAPI it's actually surprisingly easy to fix this, but this is one of the biggest problems. So the thing here is that we have a backend, like the server, the smart backend that does the ML stuff, is in a different IP and like different domain basically from the front end. So what we can do is we can allow certain special origins. In this case, we can allow our front end, which is I think 3001, yes. HTTP, sorry. I think it's HTTP. And we can just, yeah, copy a bunch of code here. And I believe that this is supposed to work. So let me just restart it just to be safe. So the backend still works as expected. Now if I refresh, oh, it did work, and we did log something, but, ah yeah, so we just forgot to include the query. So let me go back and do that. So let's put this parameter in here. In fetch, I believe you can do something like this. So I think this works, but I'm worried, like if this works, no, that didn't work. Okay, so let's just search. Let's just search instead of trying to guess. Fetch.js. Sorry, let me just read some questions from chat. The model you are currently using to compute distance between characters. The model I'm using is called UAE large, so we were looking at it earlier. I got it from Hugging Face. It's one of the top performing embeddings right now. It's free, it's open source, and it's relatively fast. So I would recommend taking a look at it. It's this one, UAE large v1, where's AI? Okay, so let's get back to this. Fetch.js with get parameters. So this is what I need. Okay, so we just need to do this plus. I always get this thing wrong. So we go back to our code. So what we need to do is a plus here. I think I did it basically correct. The only thing I messed up is it's a separate parameter. Okay, so let's go back. And oh my god, this is working. So it's always great when you see this. So if I type Counter-Strike, this is going to issue so many queries. So of course, it's not going to be ultra fast. But if you notice, the last ones, Counter-Strike is the top result. If I do, what is it doing? Path of exile. And you can see in our backend, it's getting a lot of requests. So it's getting P, then PA, then PT, then etc. And yeah, so this works. We call the backend, it gives us results back. So what would be cool is to show the results, right? So we can do that. So what we can do is instead of just displaying the data here, we're going to use state. And so this is where things get a bit complex. So I will need to, yeah, so I have my little AI assistant helping me. But basically what we'll do is we'll have search results and set search results. And we want this to be, so this is a bit tricky. So what we need to do is we need to define, we need to define what we're getting here. So let's call it search results. So search results, as if you remember, it should be something like this. It should be, let's have type game. So we're gonna have multiple things returning a game. So a game has a name, which is a string. It has this short description, which is also a string. It has detailed descriptions. It has genres, which is a string. And then we have embedding, which is a list of numbers. And every search result, we have a game in it, and then we have a distance, which is a number, right? And so search results will be a list of search results, right? And what we will do is, instead of logging the data here, I mean, we can still log it, but we can do as search results. And what we can do afterwards is that in addition to the input, below we have a div where it's gonna be let's call it results, and then we have something like why does this happen every time? Yeah, this AI autocomplete that I'm using is not the best ever, but I'm too cheap to pay for Copilot. I should really be paying for Copilot and stop paying for ChatGPT instead. So for every search result we have, at the beginning it's going to be empty. Let's say early on we just show the name, right? That's kind of weird. I thought that this would... No, let's do this. Interesting. So I can see the data being returned. It's logged. We set it. Yet somehow the results are not displayed below. Why is that? So as usual, inspecting this is the most useful thing. So let's try to figure out what's going on. So we have this, yet nothing is set somehow. Let's refresh maybe. Could be this something. Interesting. There's somehow the values are set. The game is not parsed. The game is set as a string. So the game is not actually... Okay, pandas series to predict, I guess is what we need. So let's try to change our backend such that it returns a dictionary instead. But I believe this will cause other issues, I think. Well, let's try in any case. So here, instead of to JSON, which it seems to return a string JSON. Okay, let's do query Counter-Strike. So cannot convert dictionary, update sequence, blah, blah, blah. Interesting. Yeah, there's some weird thing going on here, but I think maybe one solution is it's fine, we can still return the JSON like this. And then we can just parse it maybe. But I do not actually, this is a very, very hacky solution, but I wonder if I can just do this. Like parse myself. This is really, really bad solution. This is not what one should do. But let me see what happens if I do this. Okay, this somehow works. Again, you're not supposed to do this, but somehow it works, so I'm not gonna complain. Or actually, let me see if I just do... Does this somehow work? No, this doesn't work, okay. In the interest of time, I will use this approach. So now, if I do this again, now this seems to work. Amazing. So as you can see now, we have something displayed right below as the results are retrieved. So what we can do is we can start making it a little bit prettier. So let's say every time we have a result, and you know, result is I hate this way of writing class names. Like, I just want to write the class name. How about I just write the class name? But anyway, this is the NextJS where you have to. Okay. I somehow got lost here. Where was the div? Then h2, then div. Ah yeah, and result index. Oh, there you go. So now it looks a bit nicer. Well, more interestingly, if you remember, we have an image, right? So we can, I forgot what the image was called. Header image. Okay, so let's add that as one of the fields that we have here. There's also, well, let's start with header image. So now we're getting to a stage where it's gonna start becoming, finally it's gonna start looking like a pretty real app. So result.game.header image. There we go. Isn't that particularly exciting? Suddenly we see our little games, and I can type any game, so I can type Diablo, and I will start seeing. So there's a little bit of an issue where there's a lag. We will see how to fix that. It's kind of interesting that Diablo is not on Steam. That's why. What's a game that is on Steam? Minecraft? No, Minecraft is not on Steam. I guess, yeah, Risen is a good one. Or South Park, I guess. Is there some South Park game? No. I guess Dota is Dota 2. So remember, this is just searching by name, right? So this is not yet the recommendation part. Okay, but as you can see, we already have now a little game search engine. So I'm wondering what to tackle first. I think this search being sluggish bothers me. Like, you know, it's like super slow. So I wonder if we can fix that first. So what we want to do is we only want to search. Let's see what happens. Like, I guess when we go here, we can kind of see what happens. In that the server is it that it's stuck doing too much work? And then it's slow to answer? Okay, maybe it's actually not that bad. Maybe it's just in my head, it feels a little bit slower than it actually is. Let's do one thing. Since we're doing the work anyway, let's return the top 5 instead of the top... yeah, so now we have more games. Okay, so now that we have games, let's try to add another field. So we did all this work with recommendations. It's not to throw it away. So let's do now recommendations. So we can do another call that instead of being called search is called recommend. And so what this call does, it gets app ID, which is an integer, and we get a game, which we're gonna find this way. So gamedb app ID equal app ID. And then we're gonna do again, remember what we did with the distances? So we can go back and search it here. Where was it? Okay, so we can basically take this kind of logic and use it in our server. So, right, so we need to import this thing. And now we have this is gamedb. Actually, this is probably should be saved. Let's call it game embeddings. Oh, what did I do? I also need to do import numpy. So to avoid doing like this calculation, which is a bit slow, I'll just do it once. So now after we have distances, we sort them. And what we want to return is the top results, right? So we want to, again, we're going to do this very ugly thing of first serializing to JSON, then deserializing, but yeah, this sounds about right to me. This should be an iLock instead of, yeah. And yeah, let's only return like the top 10 most similar games. So let's do this. Let's do this thing. And let's just try it on something. So let's take one of these games. Let's do so if we go to our backend and we go to recommend, and we do app ID equal this, so we get the Witcher 3, then we get this other Witcher 3. Let's do. I do wonder if we should return maybe a subset of the data. That might make things easier. But for now, let's stick with this. So we have Witcher 2, we have Witcher 1, Thronebreaker. Okay, so this works as expected. So now we just have to call this from our front end. So remember this thing? So let's say first you search for a game. And then what do we do next? So then maybe every time you click on a game, you generate recommendations for that game, and we render them, I guess, above. Well, let's just get started, and then we can always change the UI. So what we want to do is on every game that we have here, so maybe we can do something like this. So, okay, so on every one of these games, when you click on it, so we have something like this. Every time you click, there's a fetch call. So this time, the call is to this service, and let's still use the proper URL search thing. Well, let's just keep it simple. So the app ID is gonna be game result game app ID. And we're gonna add app ID as one of the. Oh. So we fetch this, then JSON, then data, and yeah, that's our on click. And so to start with, again, we start by just visualizing the data, right? So let's see what happens if I click on data. So I get 10 results. What are the 10 results? Dota 2 Team Fortress, blah, blah. If I click on Solar 2, of course I get Solar 2 itself. So actually let's do something here where we skip the first result, because it's always the game itself. And as a result, we do it. Portal 2, Portal, The Lab, Half-Life 2, Deathmatch, Portal 9, da, da, da. So that's works as intended. So now we just need to, again, save this data and display it. So what can we do? Let's add another variable. And this is where we hit the limits. Like, we shouldn't be putting everything in one component, but now because we're trying to do things in a hurry, we do it all in one go. So let's call it recommendations. Sorry. So recommendations are going to be a list of games. And every time we click on one of these games, as we've seen before, let's go here. So instead of just logging it, we're going to do set the recommendations here. And again, like we did here, we will display the recommendations somewhere. So now to start with, let's say that we put the recommendations above the results, just to make them more visible. So we're gonna do this. And what do we need? So we need a recommendation. We don't need anything for the recommendations. So every recommendation is a game, right? So we can just do something like this. And let's start by doing this. We just want something that kind of works. So now, as you can see, I clicked on Dota 2, I got recommendation. I click on Portal 2. Oh, I click on Arma 2, I get recommendations for Arma. But of course, this UI is not very nice. So now we can move back to our styling, I guess, to make things a little bit easier to parse. So first, let's do this. Let's put a little recommendations thing here, and let's put a little search results here. So let's do this. So content h2. We're gonna take another one of those nice colors because I hate this default color listing. Okay, that's a little bit much, I guess, but yeah, let's make this maybe h1. I'm trying to I think maybe this is time actually to move to having proper components. So let's maybe this is the time. So to introduce like a new concept, new React concept. So let's do it this way. Let's create a folder called lib. Maybe inside lib we have types.ts. We move all this stuff here because this is going to be used by many things. We will also do something like this. So we will create a component called, let's call it search result. Let's say this is a search result, right? So, or actually that's a terrible name because we have a type called search result. Let's call it game view. Let's go view. I guess is not recommended for components. Another thing about it. Let's just call it game. Ah, shit, we have a type called game as well. I'm really. Let's call it game result. It's a ugly name, but you know what? Game display. All right. I'm just gonna go with that. Game display. So what will the game display be? It's gonna take these props, as we call them. So I forgot exactly how you do this actually. So let's go NextJS components. So I forgot exactly how you send a prop. Just show me the prop thing. Ah, okay. This is what I was looking for. So here we just need a game. And we need to import game. So again, I forgot how you do this. So in our case, it's something like so I think this should be fine. Ah, it's not a module. Oh my god, I'm starting to regret splitting things in this way. Like as soon as you start splitting things into files, then suddenly everything is super ambiguous. And by the way, I hope this is useful. Like we still have 10 people following, but I really hope this is possible to follow. All imports in import. All import path can only end with a .ts extension when allow importing TS. Yeah. I don't see. I really don't understand what's going on. So I might just go back to doing things the ugly way, I guess. Alright. Is this a TS config thing I need to set up? Anyway, let's do this. Not exactly sure what's going on because I think the app is working. Okay, so this is kind of working. So let's take. So what we want to do is basically here we the thing what we show for every result. Basically all of this. We wanna put it in this class. So this allows you to kind of split your code instead of being one big file. It also makes all the state thing we looked at way easier. So. For example, we can do all of this, remove the result parts. So the styles now become styles just for this file. So we can also split them in their own file. So I can go to styles, create new file. Game display dot module.css. Okay, cool. And yeah, so now every game can have its own recommendations. So that's the biggest reason we've done this. Just understood why this wasn't working. Okay. This whole time, like, what the fuck is going on here? Yeah, of course it doesn't work. So the cool thing now is we can, So we can move the recommendations here such that every game has its own recommendations. And so let me show you what this means. So, okay, now of course it's not gonna work anymore. And it's very easy because we did this thing. And yeah, in particular recommendations are not gonna make sense, but again, it's on purpose. So we have a game, we have an image, we can also show description, and below we will show if there are recommendations. So we do this. Then we show this kind of section. For web dev, I'm using, that's my job. I cannot really talk too much about my job. I mean, not in the sense, but I'm using mostly internal technology, so I don't think it would be very interesting. Let's see, I'm a bit lost here though. What is going on? So let me just figure out one thing here, and then I can answer the other questions in chat. So yes, okay, sorry. This is where I kind of got lost. So what we're gonna do is for every search result, instead of having all this stuff, we're gonna put just a very simple thing here. So now we're gonna have game display with key this and but this is a bit confusing to me. Why is this Oh. So yeah, so I was indeed, this was incorrect, right? So this is like the hard part about React. You just spend your whole day looking through lots of testing, so props, blah blah blah. Ah, right. So this is the problem. Okay. Okay, this is way better now. Okay. Now this should make sense. Well, so you put props, then the name of the prop, then the type, right? But that's kind of what I did, and somehow it's not working. Okay. I am very confused right now. So I have to say which one I want to keep here. Oh, that was really annoying. Okay, I think now it's working. So let's see. Okay, it's still not working. What is happening? Footer. Game display. I'm not sure if someone saw what mistake I made, but I'm a bit confused myself. So we have set a key, we pass the game. It's always like this, just when you think you're basically done and it's time to wrap up, then suddenly you hit some other mistake. I think it's just some stupid thing happened here, I think. Yes, of course. Like, this somehow got lost. Okay, alright. Oof, now we're back. Let's see. Don't think that's gonna... Oh yeah, it worked as intended. That's awesome. Okay, so let's see. The only thing missing is I always see recommendation even when we don't have recommendations, it still shows recommendations. So that's a bit weird. But I mean, at this point, we can also just start styling. So one thing I wanted to do here is to do something like this. So the idea is that, well, actually, I'm not sure. How do we make the recommendations separate? Well, one thing we can do is we can just we can put a different background, right? Like we can have the recommendations like this. Border radius, padding. Maybe the images are a bit smaller. Actually, maybe it's about the height. Let's say the height of the images is right. So also maybe there should be an H2, right? We'll do this, we'll do this. So yeah, maybe we also don't show all the images, I think. Like all the recommendations, sorry. So we can just show 3 recommendations maybe. Or even 2. Let's show 4. Actually, let's show all the recommendations and only return less if we want to. We can also do something like if someone clicks on recommendations, it toggles the thing. The thing that bothers me is why do we still show recommendations? Maybe I messed something up, but I thought this is how this worked. I did mess things up. No? Okay. I need to do this dot size or dot length. Okay, now it only shows recommendations if there's some. Okay, well, I'm very surprised, but we somehow managed in the 2 hours and a half that I promised to actually build the thing we promised we would. So we do have a recommender system. So, let's say, I don't know, Counter-Strike. We use this example so many times now. But, we find Counter-Strike. You click on Counter-Strike, you get recommendations. Let's do one thing. If you click again and you already have recommendations, then we remove the recommendations, basically. Let's do this that way. It's a bit easier to, yeah. So, you click on a game, you get recommendations. They seem pretty reasonable to me. So Monster Prom, you get Monster Love You. These are all like dating games, I guess. Ember Strike, Ember, which seems to be a related game, Air Mech Strike, and you can search for anything. So as an example, I think Witcher was one of the games. I have a feeling this Levenstein distance is not working as expected, by the way. Let me just give that a quick go and see if that improves the quality of the results. So what happens if I do this? Well, first, this is way faster, but no, this doesn't really work as expected. Yeah. Let's see the options in text distance. Maybe Jacquard. Well, Jacquard is very fast, but I'm afraid it's pretty bad. So let's see. Let's see if there's some comparisons. I'm ashamed to say that's... Yeah, Jacquard is usually pretty good, but somehow we're getting bad results. This is for larger texts. That's why this Jacquard doesn't make sense. I'm so dumb. Let's look at this edit. Brew edit. Is implemented here? No, it's not. Damero Levenstein. Let's just use this Damero Levenstein. Is that what it was called? Okay, let's see. Okay, I mean, this seems fair to me. It's just a bit slow. But I think the solution to make it faster is not... oh, now somehow it doesn't work. What is going on? Okay, let's just keep it simple. Let's just go with launch time, which we had earlier. Oh, sorry. I always forget. Okay, but yeah, I think we can pretty much end here because I think we're done. I mean, I would love to make this actually pretty because it looks ultra ugly right now. Maybe we can spend like 5 minutes doing that, but yeah, I'm pretty happy with the result. We have a little game recommender. It works interactively. It took 2.5 hours to do end-to-end, including all the bugs, reading the documentation and stuff. So I think that's pretty good. Yeah, maybe we can stop here. I could spend quite a lot of time improving, of course, the UI and whatnot. We could make this more interactive. But I think it's a pretty good demonstration of the fact that you don't need like a billion people to build an app, right? Like we built the data loading, data processing. We used some model that we brought from Hugging Face. We used it to get similar game recommendations. Of course, the recommendations are not amazing. There's a billion things we could do to improve them, but this is just a first start. But I can tell you, if you just make some improvements, then you launch this as a even phone app that makes it easier to discover new games. I think a lot of people would use this. I mean, today there's no easy way to find new games to play. You have to go on Steam. Steam has some recommendations, but they're not always the right ones. So I don't know if you can trust Steam because they have an incentive to sell you games, right? So they probably test whatever recommender system sells the most games. So yeah, this is already something that you could potentially put online and make it usable by people. So yeah, thanks everyone for following. Let me check actually the questions. That's a good point, and then we can end there. So yeah, I already answered, I think, technologies using from web. I answered the one about distances. I think there was a question about CPUs and GPUs. Which CPUs and GPUs would I recommend to a game? I mean, I just bought a new GPU. I'm waiting for it now, but it's very expensive. I don't know that I would recommend any particular CPU or GPU. I think it's probably better to get used to Colab and using that, because Colab gives you access to an extremely powerful GPU or even a TPU, which is built just for AI, and for free. You get access to it for free. So it's very, very hard to beat that. I think, yeah, so hardware is not that hard. I would just use Colab. And otherwise, just if I was to give a tip, get an SSD, of course. Get a computer that has an SSD. Ideally, get a fast CPU, as fast as you can afford. And GPU, I wouldn't invest too much in. It's very important for ML, but GPUs are extremely expensive. And if you have to ask me which one to get, I feel like that probably means that you don't know much about GPUs, and so probably you don't need them. So again, yeah, very fast CPU, SSD, RAM, a lot of RAM, as much RAM as you can get. I would say 32 gigabytes is probably minimum these days. A minimum of 32. If you can get 64, that's good. Because loading dataset and RAM, like very quickly you will get above 10 gigabytes of data. So if you have like 8 gigabyte or 16, it's going to be very challenging. Except if you have a Mac, that's a little bit different. I mean, the way the memory works there, maybe 16 is enough. We don't get to serve. Yeah, with Colab you cannot serve the app. But anyway, if you want to serve an app to real users, so there was also a question like this. how far are you to making this usable by 1 million people? I think, Adam, there's quite a lot of things that would need to be done, but not that many. It's not like an insane amount. So this leverage time distance we do here, we do it in a very inefficient way. So every time we recompute the distance with every other game in the list. So that doesn't make sense, right? Like if you have 1 million games, you're not gonna compute distance with 1 million. So there are ways to do this search in a very fast way. It's using some data structures. So I would do that first. That's probably the biggest improvement. The dot product or cosine similarity we do to compare games, that's also very inefficient. It doesn't have to be that slow though. There's something called, I can show you, approximate nearest neighbor. So this approximate nearest neighbor thing, maybe there's an image that explains how it works. So yeah, there's an algorithm this is one way to do it with clustering. So you cluster the whole space, and then when you search for similar games, you start by searching inside a cluster, right? Because most likely you will find 5 games in the same cluster. So this makes it way more efficient to find what are the closest vectors to me. Instead of comparing to everything, you only compare with a small number. This makes it take like 1 millisecond or 2 milliseconds instead of maybe 1 second. What else would I do to serve it? I mean, I would say, of course, I would make it look nicer. It's absolutely terrible right now. We could make many changes. By the way, just to show you, like, now we built everything. Maybe it looks ugly and you're like, oh, this is just a test out, but think about it. Like, now we built everything we need. So, for example, if I just want to make it look nicer now, I can just go here and I do like this. And I do game.short description. Bam. Now, for every recommendation, I have the description below. Right? So it's very easy from where we are now to make many, many, many changes. Not just visual, but add more data, remove data, because everything is set up. We have the recommender system, we have the backend that does the ML, we have the front end with the UI. So from here, taking it to something you would launch to users, I don't think it's an insane amount of work. Once you have the whole architecture working, one server talks to the other correctly. Yeah. So one more question, Mona. Yeah, thanks, Mona. And yes, I will try to share the code. I don't think the code is that useful, to be honest. Like, I don't think the code is the lesson here. I think the lesson here is it's not that hard, and you just have to start. And as you've seen, I made a lot of mistakes, and I searched on the documentation, and I found the answers every time. But I will still try to save the code in some GitHub repo, and I will try to share it. The video probably won't be available forever. I think I will only keep this video on for maybe 1 week, 1 or 2 weeks. So if you want to keep this video for some reason, maybe download it. But yeah, I hope to make like more videos, also in English, and hopefully better quality. As I get used to streaming and OBS. This one, it was a bit rough. I didn't have the right setup to stream at the beginning, and yeah, also I didn't share it very widely, so hopefully the next ones are a bit more interesting. Yeah, maybe we can stop here. I see that there's still some questions, but yeah, I think we can stop here and we can continue, and please like ping me. I think most of the people watching at this point know me personally, so you can just send me a message afterwards if you have any questions. Yeah, so thanks everyone, and I will see you very soon, probably at the next live stream. Bye bye. So let's figure out how to do this.